According to the U.S. Fire Administration and National Fire Protection Association statistics on residential fires from 2010 to 2012, over 9,600 residential fires were attributed to the electrical distribution system. Electrical safety should be of paramount concern when passing new electrical codes for homes. Since the 1999 edition, the National Electrical Code has recognized that standard circuit breakers cannot protect against arcing faults in all circumstances, and thus has required the installation of arc fault circuit interrupters, also called AFCIs. A proposal was submitted to revise the 2017 NEC that would reduce the arc fault protection of the cable between the circuit breaker panel and the first receptacles in a home. This wire is called the home run and can amount to 30% of the wiring in a home. The proposed change called for the deletion of what the code refers to as a listed system combination AFCI. The proposal claimed that a standard circuit breaker in the load center can protect the cable if a parallel arcing fault were to occur between any two wires in the cable. The proposal assumed that all homes in the U.S. are provided with at least 1,000 amps of available short-circuit current, and that the circuit breaker would be at room temperature. Some homes in the U.S. may be served with as little as 500 amps of available short-circuit current, such as those in rural areas or in apartment or condo buildings. Even homes that have more than 500 amps of available short-circuit current at the main circuit breaker panel may have circuits installed that are fed from sub-panels, where the available short-circuit current is less due to the resistance of the wire between the main and sub-panels. This is important because the lower the short-circuit current is, the less the possibility that a standard circuit breaker will be able to interrupt an arcing fault before a fire is ignited. Circuit breaker panels may be installed outdoors or in unheated places where very hot or very cold temperatures can affect the ability of standard circuit breakers to provide arc fault protection. The proposal claimed that standard circuit breakers can protect home run cables and that there is no need to install an AFCI circuit breaker in panels if an AFCI receptacle is installed in the first outlet box. And there is no need to have a standard circuit breaker and AFCI receptacle to be listed as a system combination AFCI. The proposed code change drove us to test some real-life situations in a laboratory. We built two models with non-metallic, or NM, cable. The tests were conducted at a UL-approved test lab. In the first test, an AFCI circuit breaker was installed in the panel, and an AFCI receptacle in the first outlet box. In the second test, a standard circuit breaker was installed in the panel. In these tests, we discovered what would happen if a homeowner were to accidentally drive a screw into a cable when installing shelf brackets on the wall, causing an arcing condition. The first model simulated a real exterior wall constructed using standard insulation, 2x4s, wallboard, NM cable installed per the code, and exterior sheathing. We used the maximum length of NM cable from the panel to the first outlet box permitted by the NEC, and 500 amps of available short-circuit current at the panel, per the UL AFCI standard. 3-inch screws were used to penetrate the wall and were centered on a stud. We cut away part of the wall for video recording of the results. In the first test, the AFCI circuit breaker trips and no fire occurs inside the wall. In the second test, the standard circuit breaker is the only protection for arcing faults. As you can see, when the screw penetrates the NM cable, the standard circuit breaker does not trip and a fire occurs. The second model tested replicated a potential attic wiring scenario. When NM cable is pulled through an attic, occasionally it may rub against a roof truss gusset plate, damaging the cable insulation. Many times the damage is invisible to the electrician as they're pulling the wire through and they may miss the damage. It may take a long time for the damage to result in a dangerous arcing condition. We use the same arrangement of an AFCI breaker in the panel with an AFCI receptacle in the first outlet box and a second test with the standard circuit breaker in the panel. As you can see, the arc fault circuit breaker tripped immediately when it sensed the parallel arcing condition. In the test of the standard circuit breaker, that was not the case. Nearby materials ignited and caused a fire. Arcing conditions like this may not be easily spotted. What does this demonstrate? That the code proposal ignored the UL standard and the real-life scenarios that can cause arcing faults in homes. We ask you to voice your concerns where proposals are raised to delete the listed system combination AFCI requirement from the code, relying only on standard circuit breakers to protect the home from parallel arcing faults. All arc fault protection devices should comply with UL 1699 requirements, as they are there for the homeowner's safety. Our ability to repeatedly cause a fire in real-world conditions demonstrates that the claim that standard circuit breakers can provide arc fault protection is false. Arc fault circuit breakers do work to protect the home from fires. Fire safety should not be compromised. Learn more at acbma.org.